Hi everyone, welcome to Eagles EduConcepts, a platform that provides you with quality education, science, and mathematics, starting from secondary level all the way up to A levels. If you are visiting this channel for the first time, don't forget to click on the subscribe button so that you can have access to more content. In this lesson, we are looking at AS level organic chemistry, and the topic is formulas in organic chemistry. By the end of this video, you will be able to define organic chemistry. Thereafter, you will familiarize with the common terms used in organic chemistry. And finally, you will know the different formulas that are used in organic chemistry. For starters, let us define organic chemistry. Organic chemistry is the study of carbon-containing compounds, except carbonates, carbon monoxide, carbon dioxide, and carbon disulfide. Carbon-containing compounds are known as organic compounds. The composition of atoms in an organic compound is expressed using formulas. There are different types of formulas. Let's have a look at the terms used in organic chemistry. Number one, we have the general formula. The general formula is a formula that represents a homologous series of compounds using letters and numbers. A homologous series is a group or family of organic compounds that have the same functional group, the same formula, and the same chemical properties. A functional group is a group of is an atom or a group of atoms which determines the chemical properties of organic compounds. Chemical properties generally refers to the reactions particularly to a substance. So chemical properties generally refers to the reactions that a particular substance undergoes. Structural formula is a formula that shows the atoms, how the atoms are bonded to each carbon atom in a molecule. So the structural formula is a formula that shows how the atoms are bonded to each atom in a molecule. Skeletal formula. Skeletal formula is a simplified displayed formula with all the carbon and hydrogen bonds removed. The skeletal formula is a simplified displayed formula with all the carbon and hydrogen bonds removed. The displayed formula is a 2D, which means two-dimensional. So it's a 2D representation of an organic molecule showing all its atoms by their symbols. Now remember, symbols of atoms on the periodic table. So the displayed formula is a 2D representation of an organic molecule showing all its atoms by their symbols and their bonds, whether they are single, double, or triple. So that is a displayed formula. Now, I'm just giving the definitions here. Very soon, you will be able to see the pictorial examples of what we are talking about. Let's have a look at them. Now, homologous series in organic chemistry. We have quite a number of homologous series in organic chemistry. So this represents an opportunity for us to understand the terms that we have just defined. Now, we have said here, as you can see, there is functional group. So there's a column for functional group right here, the first column. Then we have the second column for the general formula. Then we've got the structural formula. Then we've got the displayed formula. And we've got the skeletal formula. And finally, they give us an example of the name for that particular family. So a homologous series is a family. So the first family, simplest of them all, is the Alkane family. So now the Alkane formula, the Alkane family, they represent to the general formula CnH2n plus 2. Now, remember, we said a general formula, it represents a homologous series using letters and numbers. Now, this N here in organic chemistry, the N is going to represent the number of carbons, okay? So for example, if we are dealing with the first member of the alkanes, which is methane, then it's going to have 1 carbon. So where there is N here, it means that you're going to replace it with what? 1. Then also here we put 1. So here we're going to have C1H, then 2 times 1 is 2, 2 plus 2 is 4, so we're going to have CH4. Then you have come up with a specific formula of a member in this family here. So it's just an example. All right. So now that formula CH4, can you see when we go to the structural formula? Now on the structural formula here, you discover that every carbon, now remember, carbon is, we call it a tetravalent atom, meaning it needs 4 bonds in it to be stable. And bonds are represented by a line. So a line represents bond, and a bond represents 2 electrons. Okay, so when you look at this carbon, this is a carbon. So it has 4 bonds around it. 1, 2, 3, and 4. Even this one, this other one also, it also has 4 bonds. So this is 1, 2, 3, and 4. So now, have you seen there is this part here that has been highlighted? So this one is what we call the functional group. So alkanes will behave the way they behave because of this functional group here. And this one, we call it the carbon-carbon single bond. Carbon-carbon single bond. Because remember, a line simply represents a bond. Okay, so this is the functional group. Now, the structural formula is just how these atoms are connected to each other. It shows how these atoms are connected to each other. So the structural formula and the displayed formula are not that different after all. So here, this is an example of the first member of the alkanes. Alkanes is a family. So it's like the first bond in this family is methane. So methane, like I said, it has got 1, it is number 1 carbon. So so this one is not, it's ethane actually, not methane. So if you are looking at the second member and it has got 2 carbons, then you're going to put a 2 here. So this one becomes C2. Then if you put a 2 here, it means 2 times 2, which is 4, okay, which is 4. So this 4 here, so this 2 times 2, which is 4 here, plus 2, it becomes 6. So the formula will be C2H6, C2H6. And also when you go to the displayed formula here, you discover that this is 1, 2, C2. Then you count the hydrogens, they are 6. 1, 2, 3, 4, 5, 6. So that's what it means. Don't worry, you are just trying to familiarize with these things. So that is displayed formula. It shows how the atoms are connected to each other and what bonds are in existence. Skeletal formula, this is just where we use the what? The lines, okay? So on the skeletal formula here, we're just going to use the what? The lines. So now, when you draw a line like this one, what it simply means is, at the far end here, at the far end of the line, there is a C, okay? Then also here, in the sides here, there is a C. So this is a C and this is a C. So this is a C and this is a C. Now, every carbon, remember, it needs 4 bonds. So if you write a C here, it means that this line will represent 1 bond. So it needs 3 other bonds, 1, 2, 3. So here at the far end, we have CH3, also here, CH3. So this C and the C, that is 2. Then the 3 hydrogens that are here and the 3 hydrogens that are here, they are making 6 hydrogens, which is this one. So this is skeletal. Remember, skeletal at the ends of every line, it represents a carbon. Even if we had to put a bending, let me just try to re-emphasize on this one using a pen. So I am saying here, we can assume that there is a C. Now, a C, it needs 4 bonds. So it will need that one, okay, and that one, and also that one. So this one will represent H, H, H. So here is as good as writing CH3. Also this side, also here, also there is a C, which will also going to have 1, okay, 2, and 3. So also now these ones here, they just represent the hydrogen. So this is hydrogen. Also, this one here will represent the hydrogen. Also, this one here will represent the hydrogen. That is the rule that you should follow about the skeletal. Now, we don't show these. I'm just trying to explain the meaning. So when you draw a line, it means automatically at the far end, there is a C and there is a C. And every carbon, it needs 4 bonds. So it represents it. You are going to add 3. 1, 2, 3 plus this one already drawn makes it 4. Also this one also here, 1, 2, 3 plus this one already drawn, it also makes it what? 4. Okay, let's take for example, even if we had something like this, okay, something like this. So it means that here there is a C, also here at the far end there is a C, also here where it is bending, this is a C. Now if it is bending like that, meaning here there is H there and also there is H, so that this C which is in between will have 1, 2, 3, 4. That's what it means. So we are talking about the skeletal what? Formula. So I hope I have explained that one. Remember, we are looking at homologous series, which is a family. Now, families like you and I, we've got a surname. There's a family name. So a surname, for example, Chembe Zimba. Now, Zimba is my family name, meaning every other of my siblings. We have another sibling. Maybe there's Maureen Zimba. There's another Christine Zimba. There's Evaristo Zimba. So everybody is going to have their own name and the surname. So also here for the Alkanes, all of them, their surname here is ANE. Now this one is called a suffix. We'll look into details later on. So it's called a suffix. So a surname is called a suffix. So here in the family of Alkanes, we're going to have those things. If you remember your Form 5 organic chemistry, we had things like methane, ethane, propane, butane, pentane, hexane, and so on and so forth. So there was ANE at the end. So just take that one more like a surname. So we have looked at 4 types of formulas. General formula, this is the formula that you can use to come up with a specific formula of a certain family or of a certain member in a given family. So the structural formula is just showing the structure of that particular formula. So now, from the general formula, if we substitute according to the numbers here, the formula that we get is what we call the molecular formula. Then from the molecular formula, you can now draw the structural formula. So the structural formula and the displayed formula, it isn't very much different. Then thereafter, we also have the skeletal formula, and I've explained what that one means. All right, another example is the alkene. Okay, we also have the alkene family. So these ones, their surname is ENE. So you are going to have things like ethene, propene, butene, pentene, hexene, and so on and so forth. So ENE at the far end. Okay, so this one they are saying the general formula is CnH2n. So this N, it simply means the number of carbons. So if, for example, you have 2 carbons, if you have 2 carbons, meaning you're going to put a 2 there, then also here you're going to put a 2. So this one will become something like C2. Okay, this one will become C2, then H. So just an example. So C2, then H. Then this 2 times 2 will be 4. So this one here, you come up with a 4. So this one is what we're going to call the molecular formula. Then from the molecular formula, you're going to draw a structural formula, which is almost the same as the displayed formula. So also know that the functional group for the alkene family is actually a carbon-carbon double bond. So all alkenes, they will behave the way they behave because of this carbon-carbon double bond. All right, we proceed. So that is how it is done. So this one here, the C2H4, this is the one. You have 1, 2, then you have 1, 2, 3, 4. Now, we said every carbon, it needs to have 4 bonds around it. So here we have this a single line represents 1 bond. So this is 1, 2, 3, 4. Also here we have 1, 2, 3, 4. Okay, now going to the skeletal, also we said when you draw one line like this, at the far end there is a C, and also here there is a C. So one line represents 1 bond, another line represents another bond. So now this one, in short, it means there is a C here, and also here there is a C. So we don't just show them. So by showing this, you should be able to interpret. So here there is a C. So meaning there's an H there, and there's an H there. Also there's an H there, and also there's an H here. All right, we proceed to the next example. I hope the skeletal part is making sense. Okay, we go to another family called the arenes. So the arenes, like here, they have also explained we've got CN, H2N, then minus 6M. So here we are simply saying N in organic chemistry means number of carbon atoms. Then this M on this formula for the arenes, it simply represents the number of rings. So here it's just one ring. So this is the structural formula. Then it doesn't have a displayed formula. So the structural formula and the skeletal formula, they are just the same. So you are just trying to familiarize with the use of these 4 types of formulas that we are talking about. Okay. We also have the haloalkane. So the formula here, halo, this one is coming from, this is halogen, okay? Halogen. Now, halogen, we are talking about the group 7 elements. So group 7 elements there, we've got fluorine, chlorine, bromine, iodine, and so on and so forth. So those are the halo. So meaning, to the formula of the alkanes that we saw earlier on, the CN, H2N plus 2, now this one just becomes plus 1, then you add X, where X can either represent chlorine, fluorine, bromine, or iodine. That's what it means. So there's, I think the skeletal formula has been straightforward. So there's a C here, there's a C here, but you have put something. So when you put something at the end, don't ever assume there is a C. So for example, let me just say, if I drew something like this, this and this are different. So when I put something at the end, it means the C is not there. But if I've not put something here, it means there is a C. So here there will be a C, there will be a C at the corner here, and there will be a C here. So the difference between the C at the corner here and the C at the beginning is that this C is going to have 3 hydrogens, but this C is going to have 2 hydrogens. Remember, the rule is that every carbon, it needs to have 4 bonds around it, okay? 4 bonds around it, okay? So here, this C, we're going to have 1, 2, 3, 4. Then this one here, we're going to have 1, okay? 2, then we're going to have 3. So 1, 2, 3, 4. So this one is going to be CH3. This one is going to be CH2 because of 1, 2 here, okay? And this one will be CH3 as well. Okay, so there are several examples that we can look at. Let's look at the alcohols. Now, alcohols, there are 3 types. It's what we call the primary, the secondary, and the tertiary. But I think the major emphasis here is you just have to master the general formula. So already master the general formula. Then when you substitute into this one, for example, the simplest alcohol that we can find here, maybe if we put 1 carbon here, if we put 1 here, so it's going to be C1. Then we also put 1 here, so it's going to be CH3 or H. So CH3 or H. Okay, now let's look at this one here. This is just the primary alcohol. Then when we write it in the displayed, okay, displayed shows how exactly the atoms are connected, and this is how they are connected for a primary. Then, so here the functional group here is this one here, the OH. So alcohols behave the way they behave because of this functional group here. Okay, so here, like I said, there's a C. So here there is a C, and here there is a C. I'm just trying to interpret it for you, but a skeletal formula will just be written like this. So there's a C here, and here there's a C. Okay, then all alcohols, their names, they end with OL. Okay, so here this is ethanol. So there is OL at the end here. So this is the family name, which is the surname. So for example, let's take for example, we've got a girl by the name of Diana. So Diana one day just wakes up, she becomes an alcohol. So if we want to convert the name Diana into an alcohol, then we are going to say Thiano. Okay, so it's going to be Thiano. Okay, so Diana, Thiano. So we just add OL. All right, I hope this concept of skeletal formula and the displayed formula especially is being grasped here. Okay, so there are a lot more that we can look at. This is a secondary here. We'll explain more into details, but there's a C here for the skeletal. There's also a C here and a C here. So the C that is here, it already has 1, 2, 3. So you just need to add 1 H. Okay, so if you are adding, you are just adding 1 H. Okay, so that is the way it is. But this one is going to have CH3, CH3, and that is how it is done. Okay, We've got more and more families in organic chemistry. We've got the phenols, we've got the aldehyde, and a lot. We've got the ketones, we've got the carboxylic acids, we've got the esters. So all these, the acyl chlorides, the amines, all these, we're going to have time to look at each one of them in details. The purpose of this lesson was for people to familiarize themselves with which functional groups are present. So here, these that are highlighted are functional groups. They are the ones that are responsible for that family behaving the way they behave, reacting the way they react, and also just trying to know how to write a displayed formula, how to write the skeletal formula, and how you can come up with a molecular formula from a general formula. So that was the purpose of this video. You can play, pause, and ask questions down the comment sections. If you have any questions, then I will be able to respond to you. Otherwise, thank you so much for listening. Till next time.